This video is about using properties of triangles to find missing angles and using mid-segment triangle to find lengths of segments and measures of angles. So our triangle angle sum. The triangle angle sum is that all three angles in a triangle equal 180. So A plus B plus C equals 180 degrees. Here's why. If I label three angles in our triangle, and we draw a parallel line from through one vertex from a base. C is in the middle. A is an alternate interior angle, so this is congruent. B is an alternate interior angle, so this is congruent. When they form a straight line together, they all equal 180 degrees, so that's why all the angles in a triangle must equal 180. So in number one, we want to find W, X, Y, and Z. So if we look at our triangles, the triangle on the left already has two angle measurements. So we can subtract those from 180 to get our missing angle is going to be 75 degrees. So 180 minus 62 minus 43 gets us 75 degrees. X and Y are vertical angles, so they are going to be congruent at 75 degrees. 75 and W forms a straight line, and a straight line has 180 degrees, so we can subtract the angle from 180 to get W is 105. To get angle Z, we now know 75 and 48 in the triangle, so we can subtract 180 minus 75 minus 48, and we get that Z is 57 degrees. In number two, we want to find X, which is not inside the triangle. So we have two triangles that are overlapping. So first, I'm going to use this triangle to find the missing angle by subtracting from 180. So 180 minus 53 minus 41. And we get 80 degrees. Then we can use the other triangle to subtract 180 minus 72 minus 61. And we get 47 degrees. If we focus on this small triangle here, we can do 180 minus 80 minus 47, and we get an angle of 53. 53 and X are vertical angles, so X is 53. In number three, this question was on an SAT before. So in the figure, we know that RT is congruent to TV. We want to find the value of X. So what we can do here is we know that this triangle is an isosceles triangle, which means R and U have to be congruent. So we can subtract 180 minus 114 and split that into two congruent angles. So we get each angle is 33 degrees. Then we can look at the triangle with S, and we know two of the three angles in it because we know 31 and 33. So we can subtract those from 180. And we get 116 degrees. So to get X then, we know that it forms a straight line. So 180 minus 116 gets us 64 degrees. So X has a measure of 64. The exterior angle theorem. The measure of the exterior angle in a triangle is equal to the sum of the measure of the remote interior. So if 4 is our exterior angle, the angles away from it would be the remote interior angles. So the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So in number 4, we want to solve for X. So our exterior angle is 6X plus 13. That's going to equal X squared minus 11 plus 4X. So we can move everything to the X squared side. So X squared minus 2X minus 24. When we factor, we have X minus 6 and X plus 4. So X equals 6 and X equals negative 4. In this case, though, we can't keep -4 because 4 times -4 would be a negative angle measure, and we always have positive angle measures. In number 5, if the measure of angle 1 is 150 degrees and the measure of angle D is twice that the measure of angle E, find the measure of each angle in the triangle. So we don't know angle E, so we're going to call that x, which makes D 2x. So we have 2x plus x equals 150. 3x equals 150, so x is 50. So when we substitute x back in, we get E is 50 degrees, D is 100 degrees, and then we can do 180 minus 100 minus 50 to get F is 30 degrees. So mid-segments in a triangle, the midline theorem. A segment that joins midpoints of two sides of a triangle and is parallel to the third side has the length of half of the third side. So what this means is that B, E, and F are midpoints, and we can form a triangle. The length of these segments is going to be half of the base. So for example, if the base is 16, our mid-segment would be 8. So in this picture, our mid-segments are DE, EF, and FD. Our mid-segment triangle is triangle DEF. So in number 6, we want to solve for x and y. So y is an angle. Remember that our mid-segment is parallel to the base, which makes these angles corresponding angles, so they are congruent. So y is 72 degrees. Then we want to solve for x. So our mid-segment times 2 is equal to the base. So we would have 2 times 44 equals 6x plus 40. So we get 88 equals 6x plus 40. 6x equals 48. So x is 8. In number 7, DEF is a mid-segment triangle. Find all of the missing side lengths. So if we start with AB, we know that D is a midpoint, which splits the side into 12 and 12. EF would be the corresponding mid-segment. So we need half of the base. Half of 24 is 12. DE is a mid-segment that goes with base AC, so we need 2 of the mid-segment to get the base length, so 2 times 10 is 20. F is a midpoint, so it splits into 10 and 10. Our last side then, we already have one of the sides from the midpoint is 9, so the other part is 9. That whole base side is 18. To get the mid-segment, we need half of the base, so that segment is 9. Then we want to find the perimeter of both triangles. So when you find perimeter, you are adding your sides. So the perimeter of ABC is 24 plus 18 plus 20, which is 62. The perimeter of DEF is 12 plus 9 plus 10, which is 31. In number 8, using the mid-segment, we want to find all of our missing angles. So right now, we have one triangle with 2 angles in it, so we can subtract that from 180 to get our missing angle is 61. Then we can use our angle relationships and our parallel lines to find the missing angle. So right now, we know AB is parallel to RE, which makes 78 and 61 corresponding angles in their respective corners. Then we can look at another set of parallel sides, AC and TS. If RS is an transversal, that means that 78 and this angle are alternate interior angles, so they are congruent. If we look at those 2 angles, we know the missing angle to add up to 180 is 41, so that's going to go here to complete our straight line. Then we can use parallel lines here and the transversals. So if we look at the parallel lines and the transversals, we can put 41 and 61. We know in this corner then that 41 is missing. To finish this last triangle, we know 61 is missing. To finish the last straight line, we know 78 is missing. So a shortcut to this is that the outside triangles are going to all have the same 3 angles in the same 3 spots. And then we can look at the straight line to see which angle is missing out of each group of 3 to complete the missing angle.